Welcome to Box2d tutorials, brought to you by Bob Euland. For more information, go to bobuland.com/Box2d. This tutorial is called Introduction to Box2d. Box2d is a physics engine written in C++. That is a library of functions that can simulate the movement of rigid bodies according to the laws of Newton. You can think of Box2d as a world of invisible bodies, where the Newton laws apply. Then we have our usual Box2d world, which is a visible world. And those two worlds can communicate with each other through the update method, which, as you remember, is called 60 times per second. So, the Box2d world will harvest the positions and rotations of the invisible bodies 60 times per second, and use that info to update the corresponding sprites, which will give the illusion to the user that the sprites are moving according to Newton's laws. Now, Box2d has been around for many years, and the iPhone programmers are not the only users. There are many ports for Box2d, and here are some of them. In fact, you can see here that the Flash programmers are the heaviest users. You can find more information about Box2d at the following links. The last link is pointing to a nice Box2d tutorial for Flash written by Todd Kerpelman. In fact, it was Todd that inspired me to make this tutorial. Box2d is very powerful and has been around for many years. It has been battle tested and it works. It has many users, which means that there are people that can answer your questions. It has something which I consider very important: a good continuous collision detection. The cons are that it is difficult to learn, and it has many quirks that make the Box2d users scratch their head. Here are some differences. In Box2d you use CG points. In Box2d you use B2vec2, which are similar but not exactly the same. In Box2d you use pixels, but in Box2d you use meters. In Box2d you use degrees, but in Box2d you use radians. To make a rectangle in Box2d you use the origin point and the width and the height. In Box2d you use the center point of the rectangle and half width and half height, almost like defining a circle. You also specify an angle, which is the rotation of the rectangle. Here are the most common mistakes made by new users. Using pixels instead of meters. They are using concave polygons, while Box2d only handles convex polygons. They do not know enough C++. Now, you don't need to be an expert in C++ for using Box2d, but you must know some rudimentary facts about it. It is still possible to use Objective-C for your own code, because you can mix C++ and Objective-C in the same file. But make sure that the file suffix is .mm instead of .m. In our tutorial, we will make a ball fall and bounce on the floor. Before you do anything, you have to create a B2 world. This object will be the mastermind of the Box2d world. It will control almost everything. To create the B2 world, you use this code. You set the direction and the strength of the gravity. You set the do sleep to true, telling Box2d not to waste processing time for bodies that do not move. And then you call new B2 world. Now that you have a world, you can start creating bodies. In Box2d, you create many objects in 2 steps. First, you write the definition, and then you send that definition to some object, asking it to create the other object. Here we are sending a body definition to the world, who creates the body. Here is the code for creating a body. First, you declare the body definition, set its position, and then you ask the world to create a body. Now this body doesn't yet have a shape, only a position. And how do we add shapes to a body? Shapes can't be directly attached to a body. Instead, a shape is attached to a body using an in-between object called a fixture. A fixture does not only provide the shape of the body to an object, but also properties like density, friction, and bounciness. Here is a summary of the process. First, we create our shape and attach it to a fixture definition. We send that fixture definition to the body, which attaches the fixture to itself. Now the body knows its shape, density, and so on. Observe that you can add multiple shapes to a single body. Here is the corresponding code. First, we create a shape, in this case a circle, and we use that shape for our fixture definition. We also set other parameters, and having the fixture definition, we ask the body to create the fixture. What is a fixture, and what properties does it have? As you have seen, it has a shape, a density, friction, and restitution. It also has collision filtering flags, telling which objects collide with each other and which do not. For instance, suppose you have 3 bodies, a boy, a bike, and the ground. If the boy falls off the bike, you want him to collide with the ground. But you wouldn't want the boy to collide with the bike, because otherwise he would never be able to mount the bike. As soon as he would touch it, he would bounce. We also have sensor values. It is used to tell our game logic when 2 bodies overlap. For instance, if the boy is walking to the bike and starts to mount it, he will overlap with the bike, and our game logic might want to know that this is happening. We also have a pointer called user data, where we can put anything we want. Usually we put a pointer to a sprite, which is kind of visible costume for our invisible body. In our Box2d, we have the update method. Box2d has a step method, which it uses to drive the simulation. You specify a time step and 2 iteration counts. After the time step, you can examine your bodies for information. Most likely you will grab the position and the rotation of the bodies, so you can update your sprites. The 2 iteration counts can usually be set to 10. How do we get hold of the bodies in our code? The world has a list of all the bodies, and you can iterate the list accessing the bodies. And this is what is happening here. Let's now go to Xcode and see how we can make the ball bounce. We are inside Xcode. Let's start by making a new project. But this time we will not use the usual Box2d template. Instead, we will use the Box2d Box2d template. Let's call our project something like bouncing ball. And save it somewhere. And there we have our project. Observe that the implementation file is called helloworldlayer.mm, which indicates that we are dealing with C++. Looking at the interface file, we see a lot of stuff that we don't want to use. And the same goes for the implementation file. So I will clean up a little here and return with fresh files. Here is a cleaned up version. In the interface file, the only new thing is the import of box2d.h and the declaration of a world instance variable. And in the implementation file, we have our ratio constant where 32 pixels corresponds to 1 meter. And then we have the screen width and the screen height. Otherwise, it looks as usual, apart that we delete our world in the dalloc method. And our task will be to make a bouncing ball using Box2d. As our starting point, we have an image of a ball. The image is 50 pixels by 50 pixels. Let's start by going to the interface file and add some instance variables. Apart from the world, we have a ball body and a sprite called ball costume. We also have a counter, and we later see how to use it. Now go to the implementation file and paste some code in the init method. The first thing we want to do is to create the world. Then we want to create the room within which our ball will be confined. And then create a new ball. As the last step, we'll call the schedule update method. Let's begin by writing the create new ball method. Paste some code. The only things this method does is to call create ball costume with a certain position and also call create ball body with the same position. Let's write the create ball costume sprite method. Paste some code, and as you can see, nothing unfamiliar here. Let's now write the create world method. Paste some code. It is very simple. We define the gravity and do sleep, and then we call new b2 world. Let's now write the create room method. Paste some code. We will implement the room as 4 edges. First, we define the body and set its position. Then we create the body and attach it to the world. Our body does not yet have a shape. We first need the shape for the floor. Here is an edge that begins at 0, 0 and ends at 480, 0. We use that edge as the shape of a fixture definition. We then attach the fixture to the room body. Now that we have our shape and the fixture, it is very easy to create the other 3 edges of the room, because we can reuse the shape and the fixture definition. Here we redefine our edge, so it begins at 0, 0 and ends at 0, 320, which automatically changes the fixture definition. And then we attach the changed fixture definition to the room body. Similarly for the ceiling and the right wall. We still haven't written the create ball body method. Let's do that now. Paste some code. We do it similarly as we did for the room. First, we define a body, and here is the body definition. Then we set its parameters. The room was a static body since it didn't move, but our ball is movable. Hence, we'll set its type to B2 dynamic body. We set the position to the given point parameter. We set our user data to the ball costume. Using the ball definition, we create the body and attach it to the world. Now we need a shape and we use a circle with 25 pixels radius. Now that we have the shape, we can make the fixture definition. Then we have some additional parameters: density, friction, and restitution, which I like to think of as bounciness. Now that we have the fixture, we attach it to the body, and our body knows its own shape, density, friction, and bounciness, and that's all there is to it. Now remember that we had a schedule update method. That means that the system will call an update method 60 times per second. Let's write that method. Paste some code. Here it is. This is the place where we will transfer the data from the invisible physics world to the visible sprite world. We start by setting the world's time step to the given delta t, and the velocity iterations and position iterations to 10. Then we extract the first body from the world's body list. In our case, that will be the ball body. As you remember, the ball body's user data was pointing to the ball costume, and we retrieve it here and set the ball sprite to point to it. We then extract the position using the getPosition method and set our ball sprite position to it, and also the rotation using the getAngle method. That's everything we have to do. So let's run this and see if it works. And as you can see, it works. Before we leave the tutorial, let's have some fun. What would happen if we created several balls? Let's introduce a new schedule. Self-schedule. Selector create new ball. Set the interval to 1 second, so we create a new ball each second. And this time we will introduce the counter, which you remember was an instance variable. We'll increment it by 1. We'll slightly change the X position by 1 pixel, so the balls don't fall on top of each other. Let's check how it behaves this time. And as you can see, the balls are falling each second. And the movement is controlled by Box2d. Thank you for watching.